Hello, I'm Arnö, CEO of the MariaDB Foundation. I'm here at a fireside chat, special fireside chat with Monty. Hi, Monty.
Hi, Kai.
So you're not prepared for this any more than the audience. I'll tell the audience what this fireside chat is about. It's about values. It's about the fundamental thoughts, you often call them axioms, that have manifested themselves both in MariaDB, the code base, and in the processes around MariaDB. So how about that?
That's very interesting.
Yes, I think there are three core principles that you've been stressing over the years. You're interested in performance, you're interested in stability, and you're interested in ease of use. And we're interested in really means obsessed about. Is that a fair description?
Yes, I'm also obsessed about having the code be done in a particular way to make it easy to read and understand.
Yeah, so code quality, I think, is the core of all three of those. So I think the purpose now is for us to understand how it reflects upon code quality, your values. And what I would like to separate this into is three areas. One is, what does this mean for the code, for the product? One is, what does it mean for the process, the development of it all? And third, since your principles have been in effect for many decades, how have they evolved, or has just the world evolved? So those are the three basic topic areas that I'd like to pick your brain about.
Okay.
So the first one is then about the product here. One of your core values there, based on these three fundamentals, is backwards compatibility. So can you explain? To me, that sounds like ease of use kind of thing. Or is it? What values are there? Is that based on?
It's both based on backward compatibility. In other words, that you can run and all the client with the latest server, but also about upgrades. Mm-hmm. Because when I started with open source a long time ago, one of the problems was that when they converted a new release, especially the operating system release, always something broke and you had to go and fix it again. And I always kind of hated it, that when you get a new machine or you just upgrade something, it takes 1 or 2 days to get things back to stable. And I hated that. And I also had customers back then who were using old versions of my product, the predecessor to MySQL, and different versions. And I didn't want to go and have to upgrade everyone when there were a new bug fix or new release, but they upgraded when needed. And to make that as smooth as possible, I already in 1981 tried to ensure that everything is backward compatible, and you can always upgrade for any version trivially to the latest one without any issues, usually in seconds. And that kind of mentality that I don't want my customers to have the problems I had originally with open source. They should be spared that.
So a related topic to backward compatibility is migration. So with backward compatibility, you're in charge of the old product and of the new. Migration, there you're not really in charge of what they have been using before. So what's your view on migration?
I think that the view of MariaDB is we try to make it as easy to move from any database product as possible to MariaDB. And we don't have access to all versions of the product and everything else. So that's where we need the input from the community. That if there's a big group of people trying to move from a particular database to MariaDB, they need to tell us, the MariaDB developers, what they need so we can make it easier. And that's basically how the Oracle compatibility layer come into existence into MariaDB. We had one customer who really wanted to move from Oracle to MariaDB, and they told us that here's the things that we have to fix to make life easier for them. And we did that, and that enabled them to migrate at this point in time probably 90% of all the Oracle databases to MariaDB. But without their help and input, we would never have been able to do that.
So I think one of your values on migration is not just to make it easy to migrate to MariaDB. I think something I was very impressed with when I started to use your product is that you made it also fairly easy to migrate away in a way to with the goal to gain confidence in the product. Is that true?
Yeah, so of course with databases the internals make it hard, but we try to make MySQL dump totally generic, so you can move your data from any database from MariaDB, any database support SQL, that is. Actually, you can also use CVS files and then it works with any database. But I think it's really important that you don't put arbitrary locks of trying to keep people in. People trust you if they can easily move to you, test you, verify that you work, and if it doesn't work for some specific reason, you can move to somewhere else. There shouldn't be a lock-in with your data.
So related to lock-in, cloud is a new thing. So what's your overall view on databases and cloud, and perhaps also this vendor lock-in aspect? My personal belief with cloud is that it's a really good platform when you need to do testing, especially when you want to run with many nodes and you have a product that needs suddenly to run with 100 nodes and then go basically to 10 and something that fluctuates. But if you run something on a few servers that are 100% occupied on premise or on the ground, that I usually say, it's much cheaper and easier to manage if you have a personnel who can manage the machines. Mm-hmm. So then hardware, you were talking about on-prem or on-the-ground things. So what's the relationship between MariaDB and the hardware it runs on? And how has hardware changed over the last decade or so? How is it affecting how is the product architecture of MariaDB keeping up, and what are you working on there?
So we are working with many different vendors to ensure that MariaDB is always relevant, because if a database doesn't change according to hardware and other changes, it's not relevant after some time. So we have lots of partners who are helping us getting better uses of persistent memory, SSDs and everything else. We still have some work to get all storage engine total optimized for SSDs, but we are trying to do everything we can on the upper level. It's basically just parameters that what is the seek time and everything else that needs to be adjusted. But usually it works reasonably well. But we want to be a database that works everywhere. That's why we are working with IBM to ensure that we work on Power 8 and Power 9 and those platforms. We are working with ARM, we are working with Intel, and we are working with different SSD vendors and so on. So I think it's important to be relevant with the hardware. And also with the CPU, we have lots of internal atomic operations on the basically assembler level to ensure that we work with memory barriers correctly on all possible architectures. There's a lot of work to do to get out the last possible performance that you can get out from the CPU. But we are proud in MariaDB that we are doing everything we can to get out everything from your hardware, which actually makes MariaDB more powerful and also uses less resources. So that means that if you run it on premises or in the cloud, because we use processor better, we will use less electricity, and in that case be a greener alternative than many other databases.
So I'm too tempted to resist this temptation to ask you about threading. So threading was something that you introduced very early into your code base. And, how has that paid out? How has it worked for you? And what's your current view on the threading model?
When I started with the base code of MySQL 93, threading only existed basically in a really good state on Solaris. Linux didn't really have it yet, and not least performant, and other open source operating systems, I actually had to go and port a thread library and keep it up for SCO Unix, I think it was called back then. So things have evolved, a lot of things, and one of the reasons I used the thread original with MySQL was that actually I wanted to learn about threads, and I thought that would be a good way to handle lots of connections. And that's also the reason we had originally, and we still have as default one thread per connections. And I think that the thread model was the right choice because we can handle much more connections than other databases, because the resource for one thread is much less than one process. And also the overall context switch between threads is less than by processes. I think it was the right choice. Put some constraints how you do code, but I think it's well worth the effort.
Mm-hmm. So let's now move away a bit from the product functionality into the area of development. This is important also for the user, but very much so for those who develop the product. So I'd like to hear some sort of fundamental thoughts when I say a particular topic. So I first ask about task planning and Jira. What's your basic thinking there? What should we know?
So for doing a new project, we require some things done in particular phases. First, especially bigger projects. First you do an architecture, and you then have the people review it, and then when the article is reviewed and improved upon, you do a first version coding, and usually discuss with other developers that am I on the right track? Because the biggest problem you have in a distributed organization is that actually in the community also, that if you do too much work without talking with others, there's a big risk that either you never conclude everything because the task gets too big, or you go in the wrong direction and then you basically have to redo a big part. So a Scrum model where you talk at least once a week of where you are going, I think is the best model to get development done. Mm-hmm. I know I kind of lost the track here. So.
Well, so the track is here. I'm giving you keywords, and I'm asking for brief comments on your sort of how you apply your value set, which were about performance, stability, and ease of use. How you ensure the code quality and why you've picked certain tools. So let's go into the code repository. GitHub is the choice there. You happy with it, and how is it working?
Yes, we used several other code management systems before, but we are quite happy with Git. It allows us to more easily interact with the community because everybody can access it and everything else. And still, it's complex at times, but well worth the learning period to use it. So I'm really very happy with it.
So then I'm thinking about testing, the overall aspects of testing. There's a test suite created for and run for each of the new versions. There's continuous integration with Buildbot. There's benchmarking. What's your overall view on testing? How do you look upon testing with MariaDB?
Let's say there's very little chance that a big piece of code will work without any testing. I only remember one case within the last couple of years where I did a larger piece of code and it actually worked directly after the compiler, and I thought that something has to be wrong here. Did I really get the testing right? But usually testing finds things. That happens to the best of us. So that is why we have a very integrated test system with MariaDB, and each developer is expected to first run the test locally, the full test suite for his changes, included the new tests, of course, that he wrote, and then send it to Buildbot, who will then do testing on different platforms, compilers, hardware, and so on. And when that's done and it goes to review, and the review is accepted, then the code is accepted. So there's lots of steps, and all of these are basically tests of different ways of the software, including the review who ensures that things are coded in a proper manner.
So you consider reviewing to be part sort of the testing, well, overall quality assurance at least?
Yes, definitely.
What about code coverage? Is that an important aspect?
It is important, and we have tools who does that automatically, so that if you compile for code coverage, when you run a test suite, you get a list of here's the new lines that you added, and here's the one that is not tested. I think it's really important, and I do it for larger code changes, but unfortunately not for everything, and there we have some improvements. I think that's the main thing that we kind of is lacking a little bit, but I still think that we do better than most projects. Because the review will ensure that the test cases that you did will cover all the code, but we don't verify that. We should.
Then benchmarking, is that something that you do as part of the continuous integration, or should you do deep dive on certain topics? What's your view of benchmarking and the importance of benchmarking?
Benchmarking will help you to see that is the new code improvements that you did, are they real improvements or not, and also that you don't get regressions. So we have a benchmark teams that tests all major versions of MariaDB. We also have tests suites that are running continuously with different parameters, the random query generator. And that helps us find things. But we need to do also more with benchmarking. The thing is that with MariaDB, we are open source. Our team is not as big as the bigger vendors. So we depend a lot on the community of telling us something is wrong. Usually the MariaDB releases are stable and people are quite happy with them, actually really happy with them. But sometimes we miss something, and having a user base of tens of millions, we quickly get to know that, oh, why this query is suddenly running slower? Or why did this strange things happen? And then we fix it. So even we are lacking some parts of the development teams just because of our size, we compensate it through the user base. And the end result means that we are probably more tested than most of the data.
So let me now move to the last part of this, and this is a set of questions that I haven't yet ever properly asked you in any context. So I was reflecting back that you said that, well, in 1981 when blah, blah, blah. There's lots of developers here looking at this who weren't born then. So I'm wondering, what have you seen that has changed? I mean, some of your visionary things from the early 80s you're still proud of, but how have you changed, and how has the world changed?
The biggest difference is that the education people have about programming has changed. Back in the glorified 76 to 80s, when I started working with computers, you didn't have that many tools and everything else. And you had little resources with on the CPU and the computers in general. I mean, first machine, as we both bought at the same time, had 8 GB of memory. So you learned how to get everything out of the machine. You learn all the tricks. I also learned assembler and everything else, just to get everything out of it. And that knowledge I still using when I programming. So for every line I write, I basically thinking, how will the compiler do with this? And I try to do every functions as perfect, looking at how it will look after the compiler has gone through it. And that's a knowledge that people don't have. Back in the days when people did study everything with their machines, they did learn much more than people know nowadays. There's very few people who can go and program assembler anymore. Or when you have to go to the assembler to find a bug, people are often stumped. And what we try to do with MariaDB developers that, especially I interact with, I'm trying to learn them or teach them how to work with what the CPU really will do, and not just the code. And it's a challenge to have the code both readable and also efficient.
Mm-hmm. So, but now you sort of described what was better before, but is there something that is better today, do you think?
The tools are better. I mean, back in the days I didn't have a compiler, so I had to write assembler in hex. So things are better in that sense. Now you can get most things done with GCC, you have tools, you have, I'm using Valgrind a lot to get check for memory leaks. We have MSAN and ASAN who gives you or finds different bugs and conflicts in your code and so on. We don't have that much lint anymore, so but one of the tools that we used back in the days to verify things. So we verify more things afterwards when running. But I think it's still missing a really good lint. But things are better that, of course, CPU is better and you get more performance. You have hard disks being replaced by SSDs. Mm-hmm. So looking at programming back and then, so what is the things that has changed? In the database world, most of the code is still the same. We have to maybe adjust a couple of parameters to define what's the seek time nowadays. But things doesn't change so much. When persistent memory becomes everywhere, then things will change because the notion of sync will go away. And the databases, the biggest problem from performance is that you do sync. If sync is down to 0, you can redesign things in a totally different manner. And we have already done some changes in that. But of course it's a transition period because the hard disks, they are kind of the tape drives of tomorrow. And I think that they will be run because when you can have 10 terabytes or more or 60 terabytes on one hard disk, it's a perfect thing to still have around. You don't want to use persistent memory for that just because of the cost. But it's still nice to be able to run some part of the database on the hard disks and some the more performant things on persistent memory. So you need to still keep the old values and the new values while things evolve.
So you seem to be very fluent in most of the technical aspects of what has happened throughout the years since you started to code a database. Is there any area where you sort of have a feeling, whoa, I should perhaps be keeping up with that, but I don't need to learn everything new, that you sort of would want to know more about but haven't spent time on?
Basically doing vector programming as you have with the graphical cards. There are people doing databases up to half a tera where everything is done with vectors. That's kind of an area that I would like to learn more but haven't had time. Fortunately, there are other people who are doing storage engine for MariaDB who can benefit of the speed that you can get with the graphics card for databases, and I don't have to learn it. But otherwise, when it comes to persistent memory, hard disk, memory storage, and CPUs, I'm trying to be on the top of the curve.
So do you have any concluding words specifically for the millennial users of MariaDB as a relational database management system?
I don't see anything special with millennial users in this.
Well, they might have grown up with a NoSQL mindset and let's do everything in memory because they grew up with so many different levels of resources than you were, where you had to. When you were speaking about magnetic tape here, even so they have grown up with a different mindset. So
yeah, but so with MariaDB we try to ensure that it works on all platforms, both old and new. And even if you are born in this millennium, doesn't mean that you don't need to access the old things, even if you don't know what a cassette tape looks anymore, or my daughter doesn't recognize the old floppy drives. But still, the technology is relevant, and our job is ensure that MariaDB is relevant, not only for this millennium, but also for the next. We are trying to ensure that you can store data in MariaDB in a format that will not change and you can use to the next millennium. Try to find other databases that guarantees that.
Those were very wise concluding words. Thank you, Monty.